Okay guys, so today we're going to be looking at section 5.5. We're starting off by talking about domain. So the domain of functions is normally going to be all real numbers unless the function contains an even root or if it's a rational function. Anybody know what I mean by rational function? Fraction. If we have a fraction, that means rational. And when I say fraction, I'm talking about having an x in the denominator. If we have an even root, meaning a square root, fourth root, sixth root, the value under the radical must be greater than or equal to 0. If we have a rational function, the denominator cannot be 0 or else the function is undefined. We're not allowed to divide by 0. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. All right, first you need to get used to some new notation. When you see this kind of notation here, f plus g of x, all it means is to add the two functions, f of x plus g of x. Here's an example of it. F of x, g of x, you add them. If we see this, all it means is to subtract the two functions. Make sure you distribute the negative through when you're subtracting. Make sure you do that. When you see this kind of notation, that means you're going to multiply the two functions. So if f of x is 5x and g of x is x plus 2, we just distribute. If we have f over g of x, that means the same as just dividing the two functions. F of x, or 5x over x plus 2. What would the domain be? What value of x can I not use? X cannot be negative 2. All right, another thing I would like to show you is this notation. It's f open dot g of x. This means f of g of x. Now this is going to be new for you, so you want to watch closely. What I do on this is I work from the inside out. I look up here and I see what g of x is. It's x plus 2. So if I'm doing f of x plus 2, that means I have to take this f function, and wherever I see an x, I have to replace that x with x plus 2. So f of x plus 2, right here's my x. I have to replace that x with x plus 2. So that answer would be 5x plus 10. Now, we could have it written the other way. It could be g open dot f of x. This means g of f of x. So what's f of x given to be? 5x, right? So I replace my f of x. It's 5x. So now I have to do g of 5x. So in my g function, wherever I have an x, I have to replace that x with 5x. So this answer is going to be 5x plus 2. Notice how we got different answers for these two. All right, now we're going to do that same kind of thing with different values. F of x is 4x minus 3. G of x is x squared plus 1. Find f of g of 2. So first we're going to start with the 2, and we're going to plug that into the g function. What do we get if we plug 2 into the g function? 5. So this answer is 5. Now we have f of 5. We always work from the inside out. So now we're going to plug 5 into the f function. So f of 5 means right here's the x. And what's that going to give us? What is it, you guys? 17. Good. Let's see if we get the same answer if we go the other way. So now we're doing g of f of 2. Remember, this would mean the same thing as this. That notation means the same thing. So we're going to do f of 2. We're going to plug in 2 into our f function. So 4 times 2 is 8, minus 3 is 5. This answer is 5. So now we're doing g of 5. Plug 5 into the g function, what do you get? 26. Good. So that's our answer there. All right, let's come over here now. So it says to find f minus g of negative 4. Here's our two functions. So if I'm doing f minus g, I need to subtract these two. So to start with, it's going to be 5x minus x plus 2. That's going to be 5x minus x minus 2. That's 4x minus 2. But I'm not using an x. It says instead of using an x, I'm going to use a negative 4. So we now plug in negative 4. What's our answer going to be then? Good. All right, this one is saying to do f minus g of x and then multiply the whole thing by negative 4. Well, right here we just did f minus g of x. So we already knew that answer was 4x minus 2. Then I'm just going to multiply it by negative 4. Okay, remember what this means with this open dot? This is g of f of 3. Try it on your own. And raise your hand when you think you know. Allison? 17. Carson, agree? 17? Ian, agree? 17 is correct. Very good. All right, go ahead and try this one now. Raise your hand when you got it. Should have more than 2. 3. One more and I'll ask calling somebody. Anybody else? All right, what is it, Ian? 0. You plug negative 2 into the g function. So negative 2 plus 2 is 0. Plug 0 now, because we're doing this. Plug 0 into the f function. 5 times 0 is 0. All right, now we're doing g of f of x. So we're going to look for f of x. F of x is 5x. And we're doing g of that. Did I already do that over here? Yes, we did, didn't we? That's okay. So what is g of 5x going to be then? Just 5x plus 2. What do you think people might do on that? What do you think they might think the answer should be? Can you think of what a common mistake might be? What do you think, Ian? Sometimes they do that. Yeah, sometimes they multiply the whole thing by 5x. I see a lot though that they take this x and they multiply it by 5x and then add 2. So a lot of people put 5x squared plus 2. So I'm glad nobody did that. Don't do that. Okay, that's wrong. All right, you guys on your own now. Find this is multiplication though, right? This is not plugging in. This is actually finding g of x and multiplying it by f of x. What do we get if we multiply those two out? Carson?
5x squared plus 10x.
Good. Very good. All right, let's look down here now. It says to find f plus g of x and f minus g of x, state the domain, and then evaluate it based on the given value of x. So if I want to do f plus g of x, that means I'm going to just add these two together. They are like terms, so I can just go ahead and add. 5 of these minus 3 of these is going to give me 2 fourth root of x. 1 minus 2 is going to give me minus 1. So that's what I get for f plus g of x. Now they ask me to do that for x equals 1. Plug in 1, and what do you get? Anybody? 4th root of 1 is 1 times 2 minus 1 is 1. All right, now let's do, and it says to state the domain. What's the domain here, guys, if we have the 4th root of x? What would x have to be greater than or equal to? 0. There would be our domain as an inequality. Here it is, written in interval notation. All right, what do you guys think if we subtract and get f minus g of x? Anybody know? Got to be careful, make sure you subtract the whole thing. Eight fourth root of x, I heard. And then you have to do 1 minus negative 2. Not just 1 minus 2, it's 1 minus negative 2. What's it going to be? Plus 3, right. And now we're supposed to do f minus g of x, plugging in, or of 1 rather. Plug in the 1. What's the fourth root of 1? Times 8 plus 3. What is it? 11. And our domain for this would be the same as our domain for that. Nothing changes. All right. Last thing here, finding f g of x and f divided by g of x. And then we're going to evaluate for the given value. All right, so this is a little tougher though. I'm supposed to multiply these. So f g of x means I'm going to do 36x to the 7/4 times 4x to the 1/2. What do I get? 36 times 4. That would be the same as, what is it, 144, right? So that's going to be 144. If our bases are alike, we have to add the exponents. This is 2/4, so we're going to get 9/4. So that's what we get when we multiply. Now I have to plug in 16. What's the fourth root of 16? That's 2. 2 to the 9th. Anybody know 2 to the 9th? I think it might be 512. And then times 144. Whatever that is. Large number, right? Okay, as far as our domain on that, we have an even root. So in interval notation, guys, what's our domain going to be for this in interval notation? What is it? 0 to infinity, right? Because we have an even root on both of these. So we have to go 0 to infinity. By the way, if one of these were an even root and the other were an odd, it would still be 0 to infinity. It's the one that works that's most restrictive. That's what you have to use. All right, and now we're going to do f divided by g of x. So our f function is 36x to the 7/4. G is 4x to the 1/2. 36 divided by 4 is 9. What do we do when we're dividing? What do we do with those exponents? Subtract, so 7/4 minus 2/4 is 9x to the 5/4. Our domain is going to change a little bit now. It's not 0 to infinity with a bracket around the 0. Anybody know what other number I'm not allowed to use? Back here, what could x not be? What am I not allowed to divide by? 0. So my domain now does not include 0. The domain would have to be 0 to infinity, not including 0, because when I divide, I can't divide by 0. So there's our domain. Here's our answer for f divided by g of x. We plug in our number, 9. We've got 16 to the 5/4. Fourth root of 16 is 2. 2 to the 5th is 32. 32 times 9 is 270 and 18. Is that 288? All right. Last one, just a real quick word problem here. The variable x represents the number of pages of a textbook to be printed. The cost C to print the textbook can be modeled by the equation C of x equals 0.2x squared plus 10. The selling price P of the textbook can be modeled by the equation 0.05x squared plus 20. Find P minus C of x. So we're going to take our P function and we're going to subtract our C function, making sure to distribute. 0.05 minus 0.2 is negative 0.15x squared. 20 minus 10 is plus 10. There is P minus C of x. That's what it would be equal to. Explain what this represents. Does anyone know what that would represent if we have the price minus our cost? Yeah, it's going to be our profit, isn't it? Because this is our price, that's how much we're selling it for, and this is how much it cost us, and so this is going to be the profit. All right, any questions over compositions of functions? What is it we're not allowed to divide by? 0. We have to be careful with that with division. And if we have an even root, what do we have to be greater than or equal to? 0. Okay.